Welcome back. So the last time we left off on the product and quotient rule, we left off talking about the product rule, but we didn't yet take a look at the quotient rule. So again, our learning target is I can find the derivative of functions that have the format f of x times g of x and then f of x over g of x. So this was our last lesson. And now we're going to take a look at functions that look like this, and we're going to take the derivative. And by look like this, I mean a function divided by another function. That's how you know you're going to be using the quotient rule. So the questions that you need to know for today's quiz is, 1. How do you know when to use the quotient rule? I think I kind of mentioned that right now in the intro. 2. You're going to be asked to find the derivative of this function here, 3 over x plus 3. 3. You're going to be asked to find the derivative of f of x equals x squared all over 2x minus 1. And then lastly, I'd like to know what questions or clear understandings do you have from these notes today? Okay, so just so you know, as a heads up, these are like some rules that we know so far. We know that the derivative of a constant is 0. We know that if there's a multiple or a number in front of a function we're trying to take the derivative of, we could kind of ignore that constant and just add it in at the end after taking the derivative. We've went through the power rule. That's the basic derivative rule. We've talked about sums and differences, and our last lecture was about the product rule. When you're multiplying two functions, this is the rule, which is keeping the first function the same. Or I think in our notes I said derivative of the first, keep the second the same, plus vice versa. Same thing though. You could change the order and you still get the same answer. But for quotient rule, that's what we're going to take a look at today, which is this formula. And then our last rule that we're going to learn is chain rule. So that's just an overview of where we're at when we're learning about the rules for derivatives. And again, derivative is the slope of the tangent line, and the slope in mathematics of the tangent line is very useful. Mostly tells us the instantaneous rate of change of an object in motion, or of any instantaneous rate of something. And it will be coming up later on in applications. Okay, so we left off at example 3 in our last notes. We're going to find the derivative of f of x equals 2 all over x plus 1. So here is the quotient rule. And I like to say it like this. I say if you want to take the derivative of a function where there's a top number and then a bottom number, function or number, right? What you do is you take the derivative of the top function while keeping the bottom the same, minus, keep the top function the same, take the derivative of the bottom function all over the bottom function squared. Let's go ahead and do this. But before that, let me color code so that the top function is green, bottom function is red. All right, let's apply the rule. Notice I took the derivative of 2, and then as a reminder, everybody, the derivative of a constant is always 0. Then I kept the bottom the same, because the rule says to do that, okay, minus, keep the top function the same, so that's 2, good. And then we took the derivative of the bottom function, and the derivative of x plus 1 is just 1, because there's an imaginary 1 in front of this x. So then that's the top setup, all over the bottom squared. What's nice about this one though is that 0 times anything is just 0, so that's going to go away. So on the top we're going to have negative 2 times 1. And that's our answer. So that's our derivative. Feel free if you want to, distribute this out, but to be honest, this is fine and acceptable. All right. And again, please make sure you get this down in your notes. Let's take a look at another example. What if we have a function like this? Again, we're going to go ahead and use our quotient rule. We're going to take the derivative of the top function while keeping the bottom the same, minus, keep the top function the same, take the derivative of the bottom, all over, and then we're going to do the bottom squared. So that's what this looks like. The derivative of the top function x squared is 2x, and then we kept the bottom the same, minus, we left the top function alone, and then we took the derivative of the bottom function, and that's how we got 3. And then notice all over the bottom squared. What's going to happen in my next step is I'm going to go ahead and distribute this 2x and go ahead and multiply these two and rearrange some terms. So then once we have that, we could go ahead and combine like terms. So 6x squared minus 3x squared is 3x squared. And then we have our, that should be a minus 2x all over 3x minus 1 squared. So just fix this up because this minus this is positive 3x squared, and then this minus should still stay minus. So let's make that correction. There we go. And let's hit it back to where we were. And then, like I mentioned, you could multiply the bottom out, right? Because there's a square. You would have to use FOIL or box method, whatever method you use. Or I'm perfectly fine if you want to keep your answer like this. That's okay. Just be aware that you would know if you were to multiply the bottom out, what the equivalent answer would be. And again, if you have questions about that, just drop in to office hours. Let's take a look at a more complicated and longer example. These can get pretty long, everyone. So you want to make sure that you keep track of your arithmetic and be careful with your numbers. So we're going to go ahead and apply the quotient rule. And again, we're applying the quotient rule whenever I have two functions and they're being divided. So we're going to color code. After I color code, I'm going to go ahead and do the derivative of the top while keeping the bottom the same. Minus, keep the top the same, take the derivative of the bottom all over the bottom squared. So let's do that. So notice I took the derivative of the top function. That was, so 2 times 4 is 8, and then x. The derivative of negative 7x is just minus 7, and then we kept the bottom the same. Then we subtract, because the rule says we subtract. We keep the top function the same, and then take the derivative of the bottom. So the derivative of 5x plus 2 is just 5. That's where that came from, all over the bottom squared. Then we go ahead and do some arithmetic. So on this side, we got to do FOIL. And by FOIL, I mean we got to distribute it. And this right here, we're just going to basically distribute the 5. So these first 4 terms right here, we use the FOIL method, or the rainbow method, if you will. So for example, 8x times 5x, 40x squared. Then 8x times 2, 16x. Minus 7 times 5x, minus 35x, and then minus 7 plus 2, negative 14. And then we went ahead and distributed this 5. Notice how I, after this minus, I kept this in parentheses. That's because this minus applies to this whole second quantity. So this is actually super important. This minus is going to distribute, and it's going to change some signs. So that's actually super important to keep in mind here when these get long. Let's go ahead and combine some like terms. And what like term? Oh yeah, but before that I went ahead and distributed that minus to get minus 20x plus 35. Then let's go ahead and just combine like terms. So 40x squared minus 20x squared, that's 20x squared. Then we have negative 19x plus 35x is 16x. And then we're left over with just a negative 14. Then all over the bottom squared. So the top is already simplified as far as it can be. As I mentioned, you could feel free to just FOIL this out if you want to, but it's perfectly okay to leave it as is. All right, so again, before you take your quiz today, make sure that you understand these notes. If not, you want to come by to office hours, and then make sure you got the answers for the beginning questions down on your paper. So remember, let me go back to that so that you know what I'm talking about. So these right here, you want to make sure that you have an answer to these questions for the quiz. And again, I'm here for office hours for any support. Good luck. Stay safe.